Hello, everybody, and welcome back. We started part C on our 2011 Cayley in the last video with question 21, and now we're up to question 22. The top part of an 8 centimeter by 6 centimeter rectangular sheet of paper is folded along a straight line so that when the top section lies flat on the bottom section, the corner P lies on top of corner R. So it's not going to be a straight cut across like that. It's going to have to be sort of slanted a little bit, I guess, so that P folds over that. And then when you smooth it all out, P now lies on top of R. So that's sort of the picture, I guess, they're going for. They want the length of the crease. So the length of basically the line that cuts across our sheet of paper there. Okay, so how does folding like this work? Well, it's basically just each point up here is reflected in this line to a new point down here. So P is sort of reflected down to R. Q would actually be sort of folded over and would end up about here. That's sort of the thing. And how do reflections work? Well, the point that you start at and the point you're reflected to, when you connect them up, they make a right. So that line is perpendicular to the line of reflection, or in this case, sort of the line of fold. Okay, and that line should also be halfway between, because of course, if you imagine looking into a mirror, your reflection looks the same distance away from the mirror as you do. Reflection doesn't look like they're getting smaller. Why can't I draw a piece of paper right now? That's good enough. All right, they said it was 6 by 8. Yeah, 8 by 6. Okay. And then so we're going to have this cut along here. Now, it cuts perpendicular to PR. That's nice and important. And it also, this cut divides, or the fold divides PR in two. Okay. We just want to know, what is the length of this crease here? Well, it looks to me sort of like we could consider maybe slopes of lines, that sort of a thing, because I know to get from P to R, it's down by 8, right by 6. So that would make the slope of PR, I guess the rise is -8 over run, so -4 over 3. Every 4 you go down, you go 3 over. And this blue line would have a slope that is a negative reciprocal because, well, as I've already said, it's perpendicular. So it's negative reciprocal of slope of PR. So that would end up being 3 over 4. So for every 4 you go over, you go 3 up. That sort of a thing. Of course, I guess we're not going over 4 here because hitting the halfway point. But, okay. Now, I know to get from this point over to this point, I need to go the full 6. And so we'd be going up by 6 times 3 over 4, because that's our slope here. So that'd be 18 over 4, or I guess 9 over 2. Over by 6, up by 9 by 2. And they just want the length of the crease. Well, this should be a little Pythagorean triangle. So 6 squared plus 9 over 2 squared should be the crease squared. And I guess I didn't really need the halfway point stuff here, but that's okay. So that's 36 plus 81 over 4. I'm going to change the 36 to 144 over 4. So that should be c squared. But if you add those up, you'll get 225 over 4. And square root that should be 15 over 2 for our value of c. And so we're just looking for an answer of 15 over 2, which is, if you were to get a calculator or write it out in decimal, that would be 7.5. So our answer is going to be C. All right. So let's get ourselves a fresh sheet of paper and get ready for question number 23. I'll see you for that next time.